have to evaluate the definite integral x plus exponential raised to the power ex into dx from 0 to 4 as the limit of sums. Let's begin with the solution, and we have to find the value of this integral. And we know that by the definition of integrals as the limit of sum, integral of fx into dx from a to b is equal to b minus a into limit n approaches to infinity 1 upon n into f of a plus f of a plus h plus so on up to f of a plus n minus 1 into h, where the value of h is equal to b minus a upon n, and this tends to 0 as n tends to infinity. Now here, a, the lower limit, is equal to 0, and b, the upper limit, is equal to 4. Therefore, the value of h is equal to 4 minus 0 upon n. So this is equal to 4 upon n. Now, f of x is equal to here the function x plus exponential raised to the power 2x. So this implies that f of a is equal to a plus exponential raised to the power 2a. And here a is equal to 0. So this implies f of 0 is equal to 0 plus exponential raised to the power 0. Next we have f of a plus h. Right? Next we have f of a plus h. So this is given by a plus h plus exponential raised to the power 2 times of a plus h. This implies that f of 0 plus h is equal to, here a is 0, so we have h plus exponential raised to the power 2h. Then we have f of a plus 2h. So this is given by a plus 2h plus exponential raised to the power 2 into a plus 2h. So this implies that f of 0 plus 2h is equal to, here this term is 0, so we have 2h plus exponential raised to the power 4h. Finally, so on, the last term, which is a plus n minus 1 into h, is given by a plus n minus 1 into h plus exponential raised to the power 2 times of a plus n minus 1 into h. So this implies that f of 0 plus n minus 1 into h is given by, here a becomes 0, so we have n minus 1 into h plus exponential raised to the power 2 times of n minus 1 into h. Therefore, integral x plus exponential raised to the power 2x into dx from 0 to 4 is given by b minus a into limit as n approaches to infinity 1 upon n. So b minus a here is 4 minus 0, then limit of 1 upon n as n approaches to infinity. Then we have f of a plus f of a plus h, so on up to f of a plus n minus 1 into h. So f of a is exponential raised to the power 0. F of a plus h is h plus exponential raised to the power 2h, and the value of h is 4 upon n. So we have 4 upon n plus exponential raised to the power 2 times of 4 upon n plus, then we have f of a plus 2h, and its value is 2h plus exponential raised to the power 4h. So we have 2 into 4 upon n plus exponential raised to the power 4h, that is 4 into 4 upon n plus so on up to, this is the last term, that is n minus 1 into 4 upon n plus exponential raised to the power 2 times of n minus 1 into 4 upon n Now this is further equal to 4 times limit of 1 upon n as n approaches to infinity. Now here we have 4 upon n plus 2 times of 4 upon n and so on up to n minus 1 times of 4 upon n. So taking 4 upon n common, we have 1 plus 2 plus so on up to n minus 1 plus exponential raised to the power 0 plus exponential raised to the power 8 upon n plus exponential raised to the power 8 upon n into 2. From here we get, and finally the last term, which is exponential raised to the power n minus 1 into 8 upon n. Now this is a GP series where the first term a is 1 since exponential raised to the power 0 is 1 and r is equal to exponential raised to the power 8 upon n. Therefore this can further be written as 4 times limit as n approaches to infinity 1 upon n 4 upon n into, now the sum of first n minus 1 terms is n minus 1 into n minus 1 plus 1 divided by 2 plus exponential raised to the power 8n upon n minus 1 divided by exponential raised to the power 8 upon n minus 1, and this is equal to 4 limit as n approaches to infinity 1 upon n. Here we get 4. This is n. So we have 1 minus 1 upon n into n and 2 here. Here we have divided this n with the first bracket. So we get 1 minus 1 upon n. Then further we have plus. This gives exponential raised to the power 8 minus 1 divided by exponential raised to the power 8 upon n minus 1. Now dividing the denominator by 8 upon n, then n upon 8. Now this is further equal to 4 into limit as n approaches to infinity 1 upon n, taking n common. Here we have 2 into 1 minus 1 upon n plus exponential raised to the power 8 minus 1 divided by exponential raised to the power 8 upon n minus 1 divided by 8 upon n. And n upon 8, so multiplying this with 1 upon 8. Since n we have taken common, now this is further equal to 4 times limit as n approaches to infinity. Now opening the bracket, here n cancels out with n, we have 1 minus 1 upon n plus limit as n approaches to infinity 1 upon 8 into exponential raised to the power 8 minus 1 divided by exponential raised to the power 8 upon n minus 1 divided by 8 upon n. Right? Now this is further equal to, here this term becomes 0, so we have 4 and this gives 2 plus 1 upon 8 into exponential raised to the power 8 minus 1 into 1 upon limit as n approaches to infinity exponential raised to the power 8 upon n minus 1 divided by 8 upon n. And since exponential raised to the power h minus 1 upon h as limit h tends to 0 is equal to 1, therefore denominator is equal to 1. Since n tends to infinity implies 8 upon n tends to 0. Therefore, this is further equal to 4 into 2 plus e raised to the power 8 minus 1 divided by 8 into 1 upon 1. This is further equal to 8 plus exponential raised to the power 8 minus 1 upon 2. This is further equal to 16 plus exponential raised to the power 8 minus 1 divided by 2, which gives 15 plus exponential raised to the power 8 upon 2. Therefore, integral of x plus exponential raised to the power 2x into dx from 0 to 4 is equal to 15 plus exponential raised to the power 8 upon 2. This completes the solution.